Okay, design of shear reinforcement using Nscp 2015, part 4. Okay, this is the part 3, the problem number 3. This problem is similar to the board exam, the November 2016 exam, but of course with some modification. And iba pa yung code na ginamit dito. If you see this, if you happen to see this problem, encounter this problem into some books, probably ang solution nila ginamit dito is not based on NSCP 2015. Maybe it's based on NSCP 2010. Diba? Kasi ginamit yung NSCP 2015 is on year 2017 na. So in this case, we use NSCP 2015 na. Okay. So given the beam dimension, B times H, which is 300 times 350 by 450, effective cover of steel reinforcement is 75. Concrete strength, FC prime is 27.5. Main reinforcement FY is 415. Stirrups is 275. Beam is subjected to shear and flexural only. So by the way, these first three problems natin is member subjected to shear and flexural only. Yun lang siya. Pag may axial na siya, that's for our next problem. So this is for shear and flexural only. So nothing will change. We just follow the typical solution mga recent video natin. Diba? So I hope you, before you watch this part, you watch the first three videos, the first three parts, para mas maintindihan nyo to. Okay? So, let's continue. So, first question is, if the beam is reinforced with 3 legs of 10 mm diameter stirrups spaced at 90 on the center, determine the shear strength VU of the beam. So, VU ang tinatanong. Pero, walang binigay na loads eh. So, ang gagamitin mo ngayon is yung mga strength niya, di ba? Ano ba ang VU natin? Mari 1. Ano ba ang VU? Di ba? Ang VU is also equal to phi VC plus VS, di ba? Kasi ang VN is equal to VC plus VS. So, if you multiply phi, then it would become VU. Di ba? Yun lang naman yun eh. So, let's solve first for the VS and VC. Diba? So, all VC, if you want to solve for VC, 0.17 lambda, diba? lambda square root of FC prime BWD. So, our given is, of course, this is 1. Kasi normal concrete, di mo sinabi. Square root of 27.5, that is for given. FC prime is 27.5. So, that is less than 31.87. So, alam mo na agad ang gagamitin pag yun ang kailangan. Okay? So, BW is 350. Now, ano ang D? 450 ba ang gagamitin natin? Iba, mali ito ha. 450. Yan ang gagamitin. Kasi yung 450 is the age, not the effective depth. So, you have to subtract it by the effective cover pa. So, effective cover is 75. So, the answer is 375. Diba? RD is 375. Therefore, VC, after solving it, would become 117.01 kilonewton. Okay? So, since we have this one na, we solve for VS. Ano ang formula for VS? Area, FYV, diba? D over S. Tandaan nyo yun, ha? Okay? So, getting this, pi over 4 times 10 raised to 2 multiply by the number of legs. Ilan ang number of legs? Number of legs is 3. Sabi sa problem 3. Fy is 275. Tama ba? 275? Yes. FYB stirrups is 275. Times D, 375. all over, binigay ba yung spacing? Ano ba sabi yung spacing? 90 on center, di ba? 90 ang spacing. So, masasolve natin yung VS. What is VS? Then solve it. Assume that you solve it now, or you pause it if you think this is fast. 269.98 kilonewton. Okay? So, since meron na tayong VS at VC, diba? Meron tayong VS and BC, we can get now the VU. Diba? This is just VC plus VS. Therefore, this is just 0.75 multiplied by 117.01 plus 269.98. Then the answer, VU, would become 290.24 kilonewton. Okay? So that's the answer. Okay? So the answer for the first part is 290. 290.24 kilonewton. Okay? So that's how you solve it for problem number 1. Question number 1. Okay? So to the next question, sabi, to develop a shear strength on steel of 375. So to develop a shear strength of steel, ano yung sabihin ng VS? 375. Find the spacing of 16 mm diameter stirrups consisting of 3 legs. So binigay yung shear, merong spacing, merong diameter, ang hinahanap is spacing, di ba? So sabihin, this is spacing due to strength requirement, di ba? Ano ba yung spacing due to strength requirement? Di ba ang strength requirement galing lang dito yan? O, ito yung strength requirement. This is the VS. So if you want to get the VC, the spacing, we just have to get the inverse, ano lang to, AV, FYV, D over VS. Yun lang, binaliktad lang natin yung formula. So the answer is pi over 4 times 16 mm daw squared times 3 legs. Diba? 16 to 3 legs times Fy 275 multiplied by D, which is 375 mm all over VS, which is 375 times 10 raised to 3. Then we'll get a stirrups spacing of 165.88. Approximately, if increment of 5, the answer is 165 mm. That's the answer. Okay? Basic. So let's solve it. So that's it. 265. Ay, 165. Diba? So medyo may hirap siya sa una, pero if you get the introduction, yung first part, doon lang siya umiikot. Paulit lang siya doon. Okay? So let's continue. Kung masyado matulin, post nyo lang. Diba? Naroon tayong choice. Diba? So, part 3. Okay. Part 3. Determine the allowable maximum spacing of 2 legs. Maximum spacing ng 2 legs, 10 mm stirrups. So, maximum spacing. Kung maximum spacing to, gagamitin ko minimum area. Diba? Kasi diba, pag minimum area ang ginamit ko, sabihin kung ano yung pinaka-konting bakal, makukuha natin yung maximum spacing ng bakal. Kasi konti lang yung bakal eh. Therefore, makukuha natin yung maximum na spaces, di ba? Kasi metas lumilit ang area ng bakal, yung required area ng shear reinforcement, lumalaki yung pagitan ng bakal. Diba? So, we want to get that maximum spacing. So, ang S natin ngayon, gamit ang maximum spacing, actually, dalawa yun, yung 0.35 saka 0.0062. Diba? But since our FC prime is less than 31.87, ang gamitin na lang natin is yung AVFY over 0.35 BW. Diba? Galing yan sa minimum area. So, solving for this, phi over 4 times 10 squared times legs. Ilan ang legs? Dalawa lang. Diba? Fy is 275. 0.35. BW is 350. Then spacing is 352.62. Approximately 350 mm. Diba? So that's the answer. Diba? I hope you get it. If not, you can ask me. Okay? So the answer is 350 mm. So that's it for this problem. So I hope you still watch the next part. And the next part is what will happen if meron na siyang axial compression. Okay? So thank you for watching and see you to the next video.